Welcome to myprojectbazaar.com. Our project title: Cost Optimization Oriented Dynamic Resource Allocation for Service-Based System in the Cloud Environment. Our project abstract: because of load fluctuating, the performance of service-based system in the cloud environment may deviate from service level agreement. In the cloud environment, it is important to dynamically allocate resource for SBS according to the protected system node, so as to satisfy global SLA constraints and minimize resource cost by the analysis of complex business logic in SBS and the future of dynamic resource allocation problem. This paper model dynamic resource allocation problem as a composite optimization problem and propose the cost optimization oriented dynamic resource allocation model. Then this paper applies genetic algorithm to solve the dynamic resource allocation model so as to improve the resolving efficiency. Finally, the approach proposed in this paper is evaluated and compared with some other related algorithm. It reveals very encouraging results in terms of the quality of resource allocation. In this process, the resource allocation can be done in the certain later resources to make the dynamic cost reduce in the process level. For data flow diagram, this process first the users create the data center creation. In the data center creation, it mentions the certain number of nodes and certain process to run, and there's a service creations. And after that, the broker creation can be on the certain servers can be controlled by certain cloud provider. For example, the broker can be say agent of user transactions from file from user to other users. To the VM creation, it mentioned that the certain number of users to be connected in the certain servers. After that, the cloud creation can be on the cloud creation, the certain process to be done using the storage of a file and the reallocations of the file and data. And after the total workloads can be done, the total workloads the file can be given by the users to the data center to cloud loads. In this process, the integer value can be calculated and it mentioned that certain number of workloads to be allocated to the VM by according to the bandwidth of the processor, and it can be calculated the best fitness values in it. In the fitness value, certain number of users can be processed to the certain number of servers in it, and the top fitness values can be find out to make the allocation of the resource scheduling in it, and the task can be allocated in it. The task can mention that the certain number of workloads to the users or workloads can be mentioned at files. Then the resource allocation can be done. In the resource allocation, the certain number of workloads can be split into small workloads and allocated to a certain number of cloud to data centers. And the result can be mentioned as a graph. In this graph, the result can be provided in it. Our project demo for cost optimization oriented dynamic resource allocator for service-based system in the cloud environment. This is our home page. First, click the home.java. Right click on it and click on run file. After clicking on the process, go and this the home page is loading in data. This process, this output box, the certain output should be shown related to the console output and data. Then the process can be further. The process started. This is a home page. Click start to enter into new process. Then we are using the cloud estimation tool for resource allocation. First we want to create data center. I am creating the 5 data center in data. This is the data centers created with the certain resource allocations in a host ID and the number of machines and the bandwidth meter. And after that the broker nodes can be created. These can be maintained at a certain function process from one node to another, and the certain VMs can be created. This can be the number of users can be mentioned as a virtual machine in data. After that, the cloudlet can be processed in data, and then the number of cloudlets should be entered, and the respective cloudlets can be allocated to the respective broker nodes in data, and the VM can be allocated to the certain data centers, and the capacity can be mentioned, and then users can be VM can be allocated to a certain bandwidth in it, and the users can be processed, and the number of VM IDs can be calculated, and the total workload can be calculated. Related to the workload, the separations can be done, and the VM ID and the certain fitness values can be analyzed, and here the result of get the find out the minimum fitness to allocate the certain bandwidth with the related workloads. After that, the result of the certain workloads can be calculated in it. Here the cloud-based SLA can be processed in it. The job size related to the cloud ID can be mentioned to the certain VM. This graph it mentions the number of cloudlets and the response time to allocate the VM virtual machine in a certain process. And the resource can be allocated to the related cloudlets to data centers in data. Thanks for listening.